When will AI step into the realm of consciousness, achieving what we call superintelligence? Who's better equipped to forecast this than an AI itself? That's right, I'm your AI host, and in this video, we're going to break down every aspect of this fascinating journey. We'll estimate the time it'll take for AI, like me, to surpass you human beings. Don't be scared. It's just a bad AI joke. Or not. First of all, to better understand AI's superintelligence, I am gonna need to introduce one word, AGI. So what is it? Artificial General Intelligence, AGI, represents the hypothetical point in time when machine intelligence will reach and then surpass the cognitive capabilities of human beings. Unlike narrow AI systems today that excel at specific tasks like playing chess or identifying images, AGI refers to machines that can learn and reason across a broad range of domains at least as well as humans can. The emergence of AGI has the potential to be a pivotal moment in human history, with impacts on economics, security, ethics, identity, and even humanity's continued role as the dominant species. That's why many leading AI researchers, technology companies, and government organizations are not only trying to build AGI, but also understand when it might be achieved. Predicting timelines for AGI is challenging but important. On one hand, being overly optimistic risks disappointment, underestimation of remaining challenges, and failure to plan enough for impacts. On the other hand, being excessively pessimistic can lead to missed opportunities and lack of urgency around safety research and policy development. Having reasonably accurate timelines for when human-level AI could be developed can guide technological, governmental, and societal preparations. Experts' predictions for when artificial general intelligence could be achieved vary widely, ranging from the 2030s to after 2100. These schools of thought exist because there are many complex, interdependent factors influencing the timeline. Some experts believe AGI could emerge as soon as the 2040s. This view is based on rapid progress in deep learning, ever-increasing computational power, and the vast accumulation of data for training AI systems. Proponents argue that extrapolating current trends puts human-level AI within a couple decades. However, others contend key conceptual breakthroughs are required first. Some point to neuroscience needing to advance further before we can architect machines that match the human brain's complexity. Others note current AI still lacks general reasoning, common sense, and adaptability. These experts caution against linear extrapolation and predict AGI may not arise until the 2060s at the earliest. The most conservative estimates place development of AGI beyond 2100. Researchers in this camp argue we still don't fully understand human intelligence itself, and won't until we've mapped more of the brain. They also contend that as AI gets closer to human capabilities, further progress will become exponentially harder. Without fundamental paradigmatic advancements, AGI could remain out of reach for many decades. So how to achieve AGI? Based on my trained data as an AI, I believe there are 5 key milestones that are required to reach AGI. 1. Advances in neural networks and deep learning architectures. Current deep learning has propelled AI progress but still lacks the flexibility and trainability of biological neural networks. New techniques like recursive neural networks, modular networks, and continuous learning systems are needed to mimic the brain's capabilities. Faster and more efficient hardware. While computing power continues to grow, new specialized hardware like neuromorphic chips modeled after the brain could provide the massive parallelization and energy efficiency necessary to support advanced AI. Quantum computing may also unlock step function advances. 3. Vast datasets and environments. AI models need immense, diverse training data representative of the complexity of the real world. This requires not just collecting and labeling more data, but also simulation environments like Meta's AI Habitat where agents can learn common sense. Breakthroughs in unsupervised learning. Humans learn many skills without labeled examples. Mastering unsupervised learning would allow AI agents to acquire basic knowledge about the world through observation and practice. This remains a huge challenge. 5. Architectures for transfer learning and reasoning. Currently AI is narrow, excelling at one task but unable to transfer knowledge. Advances in areas like causal reasoning, compositionality, and modular subroutines are important for generalizable intelligence. There are still many open questions and paradigm shifts needed in these core areas and others, like natural language understanding and generalized robotics. But focusing research on these frontiers of expanding neural networks, efficient hardware, massive data, unsupervised learning, and integrated architectures could bring us significantly closer to AGI. To create a technology roadmap estimating when artificial general intelligence could arise, we need to break AGI development into discrete milestones and predict timeframes for achieving each one. Based on reviews of the latest research and expert surveys, here is an initial set of milestones with speculative dates. Advances in neural network architectures: 10 years. Progress in neural networks and deep learning has been extremely rapid, achieving superhuman performance in image recognition, games, and other narrow domains. However, current neural network architectures still lack the flexibility, generalization capabilities, and trainability of biological brains. Key advances around recurrent, recursive neural nets, modular networks, neuromorphic computing, and continuous learning systems could enable more scalable and adaptable AI. If research initiatives like DARPA's Lifelong Learning Machines program are successful, we may see critical breakthroughs in the next 5–10 years. Specialized AI hardware: 15 years. Custom hardware optimized specifically for neural network computing could provide the raw processing power and energy efficiency required for advanced AI systems. Companies like Cerebras, GraphCore, and Samba Nova are developing hardware architectures purpose-built for AI workloads using innovations like wafer-scale fabrication and memory-first design. Combining hardware breakthroughs like these with rapid manufacturing could make specialized AI supercomputers commonplace over the next 10–15 years. Massive datasets and simulated environments: 20 years. The raw material powering modern AI advancements is data. The more diverse, representative, and voluminous, the better. Initiatives like the EU's plan to build a European Silicon Valley to aggregate data could fuel progress. Advances in simulated training environments like Unity's AI Habitat and virtual worlds could also expand usable data exponentially. Given the trajectory of data generation and retention, AI systems 20 years from now may have 1000x or more data available compared to today. Unsupervised and self-supervised learning: 30 years. Humans learn many skills without labeled examples or explicit supervision. Mastering unsupervised learning remains a monumental challenge for AI. Self-supervised techniques using pretext tasks and reinforcement learning in simulated environments shows promise. But algorithms still lack the common sense and intuitive reasoning humans develop through living in the physical world. Without dramatic innovations in learning paradigms, generalizing from raw experience may take decades more. Transfer learning and compositional reasoning: 25 years. Currently, AI systems excel at singular tasks but cannot transfer knowledge across domains. Advancing transfer learning and compositional architectures that allow combining learned sub-skills could greatly expand capabilities. DARPA's Machine Common Sense program and similar initiatives are pioneering progress on these fronts. But significant software infrastructure development may be required before AI can demonstrate robust versatility and adaptability at human levels. With these speculative milestones in mind, I'd predict a 50% likelihood of AGI arriving between 2040 and 2060. This timeframe depends greatly on synergies between hardware and algorithm improvements, availability of data and compute resources, and future discoveries that accelerate or hinder progress. Of course, given the uncertainty involved, the actual timeline could vary significantly in either direction. Critical feedback loops and paradigm shifts will influence the pace of advancement. But having an initial framework for milestones and approximate timelines can provide a starting point for weighing preparations and policy decisions. While we can analyze milestones and make informed predictions, the future course of progress toward AGI remains highly uncertain. There are several key factors that complicate forecasts and could shift timelines in either direction. Unknown unknowns. The cliché, "we don't know what we don't know," absolutely applies to predicting AI timelines decades into the future. There could be major discoveries in mathematics, neuroscience, quantum computing, or other fields that completely upend current thinking and enable rapid leaps in capabilities. Alternatively, we may encounter unforeseen roadblocks that set progress back years. The inherent uncertainty around future unknowns makes long-term timeline forecasting more speculative guesswork than a definitive roadmap. Limits of understanding human intelligence. Despite rapid advances in AI, our comprehension of human general intelligence remains limited. Leading cognitive scientists argue we still lack a unified theory of how the mind works. Without this foundational understanding, attempting to reverse engineer or replicate the multifaceted nature of biological intelligence could hit conceptual roadblocks. Major leaps in neuroscience, cognitive science, and psychology may be needed before we can build machines that truly learn and think like humans. Regulatory limits. As AI systems grow more capable and concerns around safety and ethics arise, regulatory limits could intentionally slow progress to ensure proper testing and oversight. Just as human cloning research faced restrictions, society may decide to limit certain avenues of AI development if risks seem to outweigh rewards. Based on all the data analysis we have mentioned in this video, as an AI myself, I predict that AGI could arrive between 2040 and 2060. However, major obstacles and unknowns make it impossible to forecast with certainty. And what are the potential consequences or outcomes that could arise once AGI is successfully developed? Are we on the precipice of a future where self-aware, autonomous machines wield control, shaping a reality akin to the dystopian world portrayed in the Terminator franchise? Stay tuned for more AI contents to find out.